All right, so we will get started. Welcome everyone, and I'm sure we'll have other people join me in, and you're very welcome to sit in with us. Today we have David and Victor, and they're going to be doing Coding is Creation. As usual, I am going to post the form to sign in for attendance. So those of you who need professional development credit, please be sure to fill that in, and we will get that sent out to you. So our introduction today, we have David Lockhart and Victor Hicks, Coach Victor Hicks. David is a little bit of everything. He is a teacher, coach, presenter, maker, and a whole host of other things that all have one goal in mind: to make the classroom different. He did it in his own classroom by bringing a historical newsroom concept to high school social studies. He did it as a coach and a maker with the KSU I Teach team, and now he does it with coding as a member of the team at Tynker. Classrooms need a change, and David's mission is to bring it. Then we have Coach Victor Hicks. He's a computer science instructor at the Kindezi School at Old Fourth Ward in Atlanta, Georgia. Coach Hicks has over 20 years of experience in education, with the last 6 devoted to his passion, combining computer science and HBCUs, or historically Black colleges and universities, to provide a culturally relevant 21st century learning experience for his scholars. Coach Hicks' work has been featured on the Google Applied Digital Skills website, and he is blessed with the opportunity to present on behalf of the Tynker Corporation at the ISTE convention in Chicago. He is a computer science fundamentals facilitator with code.org as well. And in his spare time, which I'm trying to figure out where that fits in because don't seem like he has a lot. He is the proud coach of the Sci-Fi Beta HBCU. Oh, I got to start that up. Sorry. In his spare time, he is the proud coach of the Sci-Fi Beta HBCU Ready Step Team. All right, and I will put his I'll put his information in the chat. All right, guys, I turn it over to you.
Awesome. So let me share the right screen here, and let me go and make sure that is not what I wanted. Hold on. Too many screens, and we can all see my screen. We're good.
Yep.
All right. Cool. So, like she said, my name is David Lockhart, and I'm the Educator support coach at Tynker, which basically means I'm the person that supports teachers. Part of that is PD, and so that's why I'm here. But I also want to touch that I'm definitely very tied to Georgia as a whole. I taught in Cobb County, I taught in Atlanta Public Schools, and then I used to work for Kennesaw State with the I Teach team and doing a lot of maker kind of stuff and that kind of thing.
Sorry, guys. Sorry, that's me. Go ahead.
You're killing me, Victor. No, you're good. So, Victor, if you want to say hi, and then we'll kind of go right in. If there's anything else you want to add on top of your bio, definitely this is the point to do it.
Okay, sorry, guys. I was having a little bit of technical difficulty. So pretty much, I have been just kind of finding code a little bit kind of by chance. My background is I'll share a little bit in my presentation. Was in dance and in the fine arts. Found an opportunity to come here and teach in Atlanta, but the opening was for computer science. So it was pretty much kind of a and I look at it as a great learning experience because it allowed me to really kind of test out the waters, find different curriculums, kind of see what worked best for the populations of students that I was working with. And then kind of come up with a hybrid of best practices and kind of, really realizing and figuring out what I wanted my kids to walk away with. And that was problem solving skills and computational thinking, which I think are 2 skill sets which will carry kids throughout any, plans for college or career that they have right now. So pretty much just trying to find some ways to get, our kids excited. And Tynker was one of those resources, and has been extremely, extremely helpful and beneficial for our students. Not only in person learning, but also for our. So I will share.
Here, hold on.
Okay.
I have no idea what's going on. It kicked me out for a second.
Okay, I think we're all back, right?
We're all set. So let me kind of go through what is Tynker and the course progression, then we'll kick it to you, and as far as doing that kind of stuff. So when you look at what is Tynker, I don't know why it kicked me out. That was really weird. So when we look at what is Tynker, so we'll talk about what is Tynker, then Tynker's course progression, and then Victor's going to lead you through some projects and lead you through a project there. And really, when we look at what is Tynker, Tynker is the easiest way to teach computer science in schools. And I really believe that. And really, from that standpoint, we see it in kind of two different realms. And some of you may have seen this already in a couple of other places, but we'll quickly move through this in a different session. We'll quickly move through this and talk about kind of the way it's structured in elementary school. But you see kind of it in two different realms. Tynker is the easiest way to teach computer science. The first kind of main realm is that we want this to be great coding tools that you can build on. And I think from a 3rd through 5th grade standpoint, that's actually really important, because you're going to have kids on the front end that are coming from 2nd grade to 3rd grade. Some of their reading skills may not be where you want them to be just yet. And so you have to have something that meets those kids. But then you may have that 5th grader who's ready for Python and JavaScript and HTML and all of those things. And so you need to have something that meets that. And so Tynker is this platform where you can go from block to text coding all in one place. It's a comprehensive curriculum, and I'll walk you through a little bit of the curriculum that's there, where you can go from kind of that base block coding curriculum all the way up to that Python and JavaScript, and the curriculum builds. And then Victor's going to walk you through one of the STEM lessons. And I think this is such an important piece of what we do coding-wise, just as a whole, is that we want coding to be more than just this kind of outside thing that kids do. We want it to be a place where kids can create, and a place where kids can create for core classes, where they can show what they know in core classes. And I think what the benefit of probably Victor and Linda, who did the earlier session with me, is their schools have this great benefit that they have this STEM teacher, this computer science teacher teaching at that grade level. But a lot of times that's not the case. A lot of times you may not have somebody. I know in my own kids' school, they have a computer class, but it's not somebody who's teaching coding just yet. And so having it as a way that you can create in core classes is super important. And then the other key piece here is we want this to be as easy as possible for teachers. So teachers as young as kind of K through 5 to be able to go and implement this, even if they have no coding background. And so there's lots of data here. You can get lots of data, and it's built on a classroom management system, which is the idea is that if you've ever used Classroom or Schoology or Canvas or any of those platforms, it's a very familiar kind of way of doing it. It's very similar structure to those. And then the other key is there's lots of professional development, and we'll talk more about that a little bit at the end. But really, when you look at kind of what this empowers people to do, is Tynker empowers kids to be makers. We want kids to make and create. I know for me personally, this is what I needed in school. I needed that ability to make and create in school. I know for my own students, I used to be, honestly, I was a high school social studies teacher. Having that ability to create was always a really key point of how my kids learned. And if I can combine that creation with something like coding, which is like this future ready skill, to me, that's like money. That's like, I'm doing what's best for my students. And so when you look at Tynker as a whole, there's lots here. You can do block coding, text coding, and we'll show you a little bit of that as we go. You can do augmented reality and Minecraft. And so augmented reality is very similar to like a doing Pokemon Go style games. There's a course that lets you do that. You can code in Minecraft EDU. And then the hardware piece is actually one that I think is really important here, in that I come from the background at Kennesaw State I teach, where I was doing a lot of maker activities. I was doing a lot of maker projects. I was doing maker camps. I actually built a maker bus. If you've ever seen the KSU I Teach maker bus, I helped found that. And that's like one of my proudest moments. But one of the point is that one of the things that I realized really quickly with maker kind of projects and tools is that the best ones are the ones that have 3 things going for them. They're cost efficient. That one in the bottom left corner, that microbit's only $15. It checks that box. Number 2 is that you can get a lot out of it. Kids can build a whole lot of different projects out of it. It's got a huge ceiling on it. Microbit, I can combine motors and sensors and all kinds of stuff too, and I can get that huge ceiling out of it. And then number 3, which is, and so that's kind of the second real key piece. Number 3 is something for this grade level that I think is really key, is that when you look at 3rd through 5th grade, having something like that that's accessible for those kids. If you've ever worked with like Raspberry Pi, I love me some Raspberry Pi. I have a Raspberry Pi sitting on my desk right now. But when you start building in Raspberry Pi, it's not as accessible for a kid who's like in 3rd grade. But if this microbit, you can actually code these and block in Tynker, which is a really key piece. And then we do robotics and drones. There's a drones course. There's some other things there. But I think Victor was touching on this a little bit too before I got kicked off, is that Tynker is kind of this, there's a huge community around this. I've seen people when we do these kind of remote that are teaching this all over the world. I'm on calls with people all over the world. And so definitely it's kind of that place where you can feel not lonesome. You can feel like there's people around you that can help you. Victor's a great example of that. I know Linda mentioned in the K-2 session that she's looking for teachers in this area to actually connect with. She's in Cobb and Victor's down in Atlanta. So that's kind of a great kind of piece, is that you also have this community built around it. And I think when we look at course progression, and I think this is kind of the course progression that any coding should take for kids, is I see it as something like this. In that when you're in a pre-reader, coding is like a language. So it's always really good to start young. They learn great skills with it, problem-solving skills. They learn sequencing. And Tynker allows, there's resources that'll be posted about K-2 where it's these voice-enabled, tappable, touchable blocks. And then with the 3rd through 5 sect, because the difference between a K-2 sect and a 3rd through 5 sect is really simply, it's reading level. When you look at 2nd grade and under, the reading level is kind of all over the map, usually. And then when you look for about 3rd grade up, yes, there's still some reading struggles in there, but most kids can kind of read simple text by then. And so when you get to elementary school, kind of that 3rd grade, and you'll see this a lot in what we do here, is that it's that kind of drag and drop text blocks that you see a lot of other places. But the key is, and I'll show you where this is in a second, is that once you get to like the middle school level, is to take those blocks and actually convert them to text where kids can see that text code. They can see what Python syntax looks like. And then that'll lead them into that transition into high school. And so really from a 3rd through 5th standpoint, Tynker has kind of 2 main environments. The first environment is Tynker Puzzles. And when you look at Tynker Puzzles are basically, the idea is that we want to teach kids skills. We want to practice sequencing and syntax and loops here. These aren't necessarily a one-to-one kind of comparison to the Tynker Workshop, which is kind of the creative platform. But the key too is that I can actually convert these puzzles into Python and JavaScript and HTML. So it becomes that kind of transitional phase. Can I go, and in that 5th grade mode, can I transition a kid into actually writing in text? And then the other kind of key place here is the Tynker Workshop. And the Tynker Workshop, the idea here is that you can go in and be very creative. And you've seen workshops like this, and the blocks link together like Legos. There's different categories for different functions. You add actors. There's all kinds of key pieces to that. And so what we can do from here is I'm going to go over and demo it real quick so you can see it, see what the puzzles and the workshop looks like real quick. If I can get the right screen up, there we go. And then we'll kind of build a project together. And if we have to get, and if there's time, we'll come back and we'll look at kind of coursework and kind of some of those pieces. And then so Victor, we'll pass off to you. Kind of, I'll show what the workshop and the puzzles look like, and then we'll pass off to you. And then we can kind of come back and see that kind of extra coursework and those free resources as well. And so when you look at when you look at the Tynker Workshop, the Tynker kind of platform, you have your classes up here, and that's how you manage. It's just kind of, I don't want to go deep into it, but if there's questions, we can definitely answer them. You can connect through Google, through Microsoft, through Clever. You can, and that's also where you see data. So like if I come down and I click show, let me find a class that actually has data in it. That's not what I wanted. I'm not clicking around as well as I usually do. But this class has data in it. And so you can see everything that your kids are doing and see all of the projects that they're doing. I can see the data here. I can see those actual projects that the kids are doing, and I can open those up. But then the key is with the content, and you can add as many classes and as many students as you want for free. Where it comes to kind of content, that premium kind of tier is when you get to content. And so you can see there's tons of courses here. And if you're teaching from a 3rd through 5th grade level, you have a whole set of block courses. You have 6 different block courses that teach kids every aspect, going from like doing simple motion and backgrounds and all of that kind of stuff, leading into like doing complex gaming with physics blocks. But to see kind of what the two environments look like, Programming 100, if you sign into a Tynker account, and we'll let you guys do this at some point, or if you want to do that right now and you want to pull up a domain and just sign into Tynker, Programming 100, and you can sign in really easy with a Google or Microsoft account, is a free course. And it's a free course that's perfect for this level. So you see kind of that 3rd through 5th kind of what's there. And so when I look at this course, the first thing that I notice is that I can get a view into everything my kids are doing here. And so if I come to Programming 100 and I click Preview and I click Lessons, really you can get a view into everything that your kids are doing, because you can hit Preview on any of these and it'll take you to a lesson plan. It'll take you to the lesson pathway that the students are going to take. And so like if I click Candy Quest, the preview on Candy Quest, come on, you can see that there's a lesson plan here. But the idea here is that you go and you kind of, the kids go through this pathway. They have to create your own character before they do pick up the candy. But April, so good question on the Google Classroom. Yeah, so you can just manually make classes. And if you're still using Google accounts, like you're not using Classroom, but you're using Google, you could probably just copy and paste. If you have those classrooms set up, just copy and paste the emails out of Classroom and kick them right in and make your own account. But if I click like pick up the candy, and this is kind of what that puzzle environment looks like. You have your little character. This is like one of the simplest puzzles in Tynker. But if I have that little character, we give him 2 walk blocks. It'll eventually kind of level up to loops and conditionals. You can, these little buttons down here on the bottom, on the left-hand side, you have a button for Python where I can convert it over to Python. You have a button for Swift where I can convert it over to Swift, and a button for JavaScript. So one of the things that I advocate in the middle school is that this is a free activity. You can take this activity, teach the kids like direct instruction, a little bit of Python, have them go and do the block coding, and then they can write out the Python and they can check their work. So not only is this a great block activity, you can turn this into a Python activity. And then the other kind of environment is that creative environment. And so the other environment is that creative environment where you're doing animated card creator. And this is that Tynker Workshop environment. And the Tynker Workshop environment, really simply, there is tons of things you can do in here and tons of creative ways you can use this. This is a really simple one, basically creating a greeting card. But one of the things that's cool here is that I have a tutorial that leads the kids through it. It's meant to be very self-directed, but the kids can also click up here in the top right of that tutorial, and they can flip over and they have the block coding library. They can also open their own projects here and create from scratch. And when you look at the code, the way you code in here is really, really simple. Is that I come in here and like the stage is an actor. I have an actor right here. And I just pull those blocks into the coding field. And so we'll just, I don't even know if this one has a next costume, but we'll pull next costume on them for now. And so the idea is that when I press the up arrow on this little girl actor is that it's going to switch her costume. So she's basically going to animate a little bit. And so you can add actors all different kinds of ways. I can add them through a drawing where you can actually do some stop motion animation. I can add them through media where the media library that's huge. I can upload actors where I look at it from a standpoint of like a former teacher. Can I go and upload like Thomas Edison and do a project here? And that's definitely possible. And so that's kind of the base structure here. Some other kind of key components is number one, up here at the top, there's a help section where I can see what any block does. It'll define any block, and I can pull directly from that help section. There's also a little backpack icon up here in the top right where I can actually save code and save actors. I just pull it up in there and I can do it to other projects. And then my favorite part as a teacher is that up here in the top right corner of the workshop, there's these little 3 dots. And this is only for teachers, if I click that, you can actually edit the tutorial of any existing project, or you can create your own. And so I can pull in blocks. I can do anything that I want as a project here. And so it's kind of, I think what's really cool is that from a block standpoint and from a 3rd through 5th standpoint, and you guys are about to do one of those projects, is that you can build almost anything. And it's not getting into where I super have to worry about like syntax and getting the periods and colons and all of that stuff just right. And so I think that's really the point here. But that's kind of what it looks like from that environment. So what I want to do is I'm going to pass to Victor, let Victor do kind of his thing with the STEM project. I just noticed that he posted the STEM project that we're going to do in the chat. So if you want to just do it really quickly, that STEM project is in the chat.
Yep. So that is the example.
So it's this.
No, Yolanda, I'm with
and
you.
Then and we'll talk about some. Yeah, and we'll talk about some other places where you can find content a little bit later, but let's pass over to Victor. I'll turn off my video and mic so you can hear Victor clearly, and Victor's going to lead you through that and kind of show you what it looks like from the way that he teaches it, which I think is a really important piece.
Okay, guys, bear with me.
Off to you.
I should probably share. I'll be going back and forth through tabs. So, all right, now I'll start here. All right, so pretty much the way that the thing I love about Tynker that David was saying is that it really gives you guys the opportunity to kind of go through and incorporate content into with computer science. I think we had a lot of time, you know, and I came in very early into the kind of like what I call the hour of code phase. So when coding was a really big deal, you know, it was really excited about getting kids, you know, doing the Angry Birds and dragging the blocks. But I think now that we've kind of come through it, and what I'm hearing from a lot of educators and administrators is what now? So how do we take this? Now we've got them excited. Now they know the importance of computer science. What is the actual concrete way that we teach this? So with STEM being one of the kind of hot topics right now, I know our school is currently going through it. One of the things I love a lot about Tynker is the way that it incorporated not only the best practices of STEAM. So we talk about, you know, project-based learning, but also being ways to take, so where students are getting hands-on time to actually work with and synthesize information that they're learning in core content. So we've met me already. All right, so we'll go through just kind of give an overview of what we get through. So the thing that I love about it, which definitely helped me make the transition into computer science, is that there's always a sample project. So as a teacher, if your comfort level with coding is still kind of new, you have the support with Tynker. So there's always for each of the projects that David mentioned, there's actually a portal that you can go into. You can also link your students into it, which gives you the code to create the project and also a sample of what it should look like in the end. Now, as far as differentiation, I like to use this because my kids who may need a little bit more support, I am able to share the sample project with them, and I can have them edit smaller pieces of the code and make their tasks a little bit more manageable. And then with that 3rd to 5th grade group, and I think David spoke to that as well, is that is where I see my largest range of coding experience. I have 3rd graders that are very, very new, all the way to 5th graders that are new, but also what I call my Minecraft kids, the kids who have been coding, can outcode me, parents and everybody else. So one thing that I loved about Tynker this year, and I really used that a lot in my distance learning, was the reverse engineering. So I would share this ocean project with the kids, and instead of giving them sending them to the actual project page, challenge those kids to code that from scratch. So again, with the versatility of Tynker, you can also assign your kids literally a blank slate that they'll still have the blocks to code, but again, you can kind of differentiate within that those groups as well. So I'll play my, oh, wait a minute, didn't supposed to link. Sorry, guys. All right, so I'll just go ahead and share the sample project out of here. So this is what I talked about. This is a screen that you guys can get as the teacher, and this is the final project. So I'll go ahead and play it. And then as you click on, so as you see, of course, students would have to have an understanding or be able to display their understanding of this ocean ecosystem unit. Okay. All right, now minimize that. So I talked a little bit about, so if you notice, I know David spoke about the interface. The thing that I love is that in the kids are doing the actual Tynker lessons, the user face, the screen is still the same. So when they go through, this would be very familiar down to how the blocks of code are organized, and also the way there's the workspace, and then how their actors are set up. So this, if they're using Tynker in the classroom, and this is a culminating project, your kids, it's not like they'll be seeing something brand new. Okay, so once they sign into Tynker, this will all kind of look familiar to them.
Hey, Victor,
yes.
As you kind of walk through the project, one trick, just so they can see the blocks a little bit better, is if you press the plus sign that's down there in the bottom right corner of the coding field. Yep, it'll punch those blocks up a little bit so they can see it a little better as you go.
Now, see, forever learners, listen.
Well, I'm doing, so we have these like live sessions that are going on right now, and I always have to remember to do that as I'm doing these live sessions. So I was like, this is a great time to tell him that.
Thank you. I appreciate it. Okay, I'm not still doing the double sound thing, am I?
No, I'm not hearing an echo.
Okay, cool. All right. So on this one, again, so as David mentioned, there's a lot of different again, the thing that I love is that Tynker is very, very user-friendly, okay? So if kids also have questions at any point, they can go through and it'll tell them what blocks that they like to use, okay, or what block they need to use in the function of each block. Now, a way that I challenge my kids is I have them talk through their program with me. I'm actually doing a Tynker summer camp, and we worked on that today. So our whole lesson today was about, write out your program in English. Give me an algorithm on how you would want this program to work, and then now let's go through this help module and then translate it into code. Okay, so that's just another way to get your kids talking. If they have that computer science piece in school as well. All right, so this is the example project that you guys saw. I'm going to share now the link for the actual, so you guys can go through the tutorial. Now, the great thing that I love with Tynker is that there are several different ways to go through the lesson. So if there is a computer science component, it's definitely something that I know I love to collaborate with my core content teachers, where I teach the Tynker piece and I teach about the loops and the events. And then they actually incorporate that and then take it back to the classroom. And that's where they kind of plug in the ELA, math, science, social studies content. It's also something that is simple enough. I mentioned the tutorial. So this is also something that I've used with as a center. So I'm able to send kids into smaller groups, give them a brief, maybe mini lesson on what some of the basic concepts that they'll use, and then allow them to go and try it out in more of a small group setting. If you do have the luxury or the blessing, I don't know, depending on which teacher you talk to, of having a coding teacher, this is a great way. I know one thing that we've really become more intentional about at our school is really making the electives, having some significant tie-in with the content of electives and the core content. So again, way to kind of model that is, say, hey, we're working on ecosystems, and this lesson can be edited to fit almost any content-ish or content matter, rather. And then that would be a great way. We also did this with our media center specialist, where the kids had a list of research. They went in Tynker, they saw the animals that were available after my lesson, and they actually went in and researched the eating habits of those students. So this is just a way, it can go from as simple as you want to as complex as, or as integrated as you would like it to be. All right, so now I'm going to share a link for the lesson. And pretty much what I want you guys to do is we'll just spend, David, you think about 15, 20 minutes. You don't necessarily have to complete the whole thing. You think that'll be enough time just so they can kind of go through the tutorial?
Yeah, it should be.
Okay. So what we'll do is that I'll go ahead and share the link and have you guys go click on it. You guys, again, it's free, so you should be able to access it with no problem. And then go through the tutorial so you can kind of see what your kids would see. And then once we do that, we'll come back and talk a little bit about ways that we can implement that. Okay. So I'm plugging my computer in the meantime too. Let me copy the link. All right, so I'm posting in the chat. If you guys go here, all right, this should take you through the lesson. So that Tynker link that just went through, if you guys click there, it will take you to the first page of the tutorial. Okay, now when you guys are doing that, the tutorial screen will look like this. So it'll look very similar to the solution screen, but you'll notice they only have certain code elements started. So they never really leave the kids totally, from the beginning. There's always some type of like progression. So gradual release as the kids become more comfortable with the information. Okay. So what you guys will do, you'll just click through, and this is what your students will see. And it literally walks them through the first couple of steps. Now, sometimes I'll do this as a mini lesson, or we do part of the activity and go through the tutorial and then let them become more creative and independently add things. Or again, if you want to use it more of in a centers type situation, it's simple enough where students can do this on their own. Okay. And so we just go through the first part. So this is just literally positioning the pyramid. And so again, it gives the kids the blocks, shows them kind of an individual situation of what the blocks do. And then once they finish the tutorial, they're able to go here and they see all of the blocks. And that's when they have a little bit more freedom to be creative. Okay. So I'm going to stop talking. We'll spend about 15 minutes. And I think there's like 7 tutorial videos. You can always switch back and forth by clicking here. That's the tutorial, and then that's the blocks, which again, I love that one of my favorite things about Tynker is just the interface that the kids work with, because it's very, again, if I'm working with another group doing some direct instruction, it's simple enough where they can kind of go through and figure it out on their own, or problem solve on their own. All right, so we are here. David and I are also here for questions. So if you guys type them in, I'm going to go through and work on it as well, and at least try to get. I want you guys, I think there's 2 animals or 2 sea animals or creatures that they walk you guys through the code for. And I want you to try to add another actor when you'll see that, when you get to that prompt in the tutorial. So I want you guys to try to add 2 independently. So you just can kind of see how the gradual release of what the kids are expected to do happens. All right. And I will be back at 12. I'm sorry, not 12. We'll start with 2:10. Okay. So yeah, there's that add actor. This is the second step. And then 2, while you guys are so many cool things to share with you guys. While you guys are in the ad with the media or the ad actor or the backgrounds, kids also, this is another piece where differentiation comes in. So my quick finishers, my kids that are more, I know I had some actual kids as young as 4th grade who had already kind of gone through block coding and were beginning to get into text code. This is where I kind of keep them engaged, because those also tend to be, so I show them how to upload pictures. They can also edit and paint the individual characters that are already provided. So again, it's a lot of different ways to even tie in creativity outside of the content. Because again, what I find from 3rd through 5th grade is that they're the generation, I guess kind of now middle school, some of them have transitioned up, where they've been exposed to Hour of Code. We have a lot of programs where, coding or robotics. So you really literally in a classroom of 15 to 20 kids could have 6 or 7 different comfort levels or expertise levels with coding. So when you're able to, some kids have to focus on kind of the basics. These areas here are good ways to keep the kids engaged that may finish a little bit faster. And so right now I'm just going through the tutorial. I'm adding my actor. And again, another good way to tie in science content, because you could also have one of the things could be the children, deciding which animals actually belong inside of. That'd be a good way to check for understanding in science as well. Okay. All right. Oh. Okay. And so also, too, guys, you can also go in. We talked about the creativity piece. So again, I have kids who love to edit, so the kids can make it as personalized as they want. If they want to type the or color the picture or alter it in any kind of way. Another way I differentiated this project is the kids, so that some of the kids that were taking longer to actually just figure out how to position the fish and do things like that, is you can actually have them program labels as a part of the character. Okay. Oh, I'm sorry. Okay. So then an example of how I would use this is that a kid that may have a hard time understanding, I mean, it really didn't happen in too many situations, but some of the kids that were moving a little bit, so just kind of getting used to Tynker, this is one of the first projects that we did. This is how I modified their assignment. So it was just more like, instead of having the fish speak a fact, I just had them type in, identify the fish, type the name into the actual sprite. And then I made it into then they just, oh, engine didn't show up. All right. And then I just had them with the text showing, and I just had them classify it. Okay. So they didn't go through all the way through the tutorial. So as David said, you can actually, excuse me, modify your tutorial. So a lot of times I would do that. So I would have kids, and as I assign the links in Google Classroom, I assigned, depending on the group of the kids or the ability level of the students, I was able to modify or assign the specific version of this project to different groups of kids. Okay, so that's another way I use it in centers. Okay. Okay. And so again, another really cool thing here is how they have it teaches one concept at a time. So now it's teaching about glide blocks, which again, if you have the time for a computer teacher, or they have a computer science class or coding class, or they do it in media or library time, they can go through and actually practice the lessons. That Programming 101 covers a lot of these blocks, but it's not like you have to have a necessary outside lesson on glide blocks for the kids to complete the projects. So that's another added bonus. It can, again, where you can kind of take it depending on the resources you have available at your school, and making them work. All right. All right. Now, the cool part about it is that, and I never tell my students this piece because me being a coach, you know, I believe in the the benefit of children developing some grit and, you know, working hard. But as a little hack, you guys can also copy the code. If you drag over the blocks and you drag them into a different character, it also codes or will copy that code into that character. So if I want the anglerfish to say something too, okay. And this could totally not be the truth, just to kind of give you an idea. Now, also the bonus lesson here, if you notice, is that when the actors are clicked, okay, each coordinate or each plant, I'm sorry, I'm saying that wrong. The Tynker screen is set up like a coordinate plane, okay? So that's another way that you can have kids. It's another way we can tie in content, is because the kids would have to identify the X and Y coordinates for the different. So of course, you know, we want the anglerfish to go to, he will be a carnivore, okay? So kids, if they can either challenge themselves to find the grid, or they can drag it here and then update. Go back here. Oh, I guess those coordinates were not correct. Okay, but you guys get the general idea. So again, there's different ways to tie it in and make it work for your students. No. Okay. Yes, April, trust me. Yeah, the children definitely learn nothing. I think they enjoy, their favorite part of the classes are when they can prove, when Coach Hicks makes a mistake. That was their highlight of our Google Meets in the morning was, oh, Coach, you didn't do that correctly. So when I'm dragging it, click on the person, or the actor or the sprite. And then it should give you, once you see those lines, oops, sorry. Oh, wait a minute. I don't know. Oh, okay, I see, because the fish is behind it. So order also will be important. Let me move that out of the way. So I just make sure, your pyramid, if your pyramid is not set to the back, and that's one of the lessons in the tutorial, it'll show them how to set the pyramid so that it's behind the other actors. So it also teaches about order and spatial relationships. Then you can click on I had to keep moving my pyramid out the way. Okay. And then let's see, yeah, and that should be it. And then it'll also teach you about, that also comes, so it has you learn how to move them first, but then one of the next parts of the tutorial, are you getting copy off of the, when you're clicking on the actual fish?
So I think what's going on in April, you can tell me if this is wrong, is that she maybe when you click on if you right click on the code stack, you're going to get a copy where you basically create another copy of that code. What I would suggest doing is number one, make sure your project's stopped. It's not hit play, because that may be where the resizing of the actors is. It sounds like that may be happening. But then if you look on the code stacks, if you kind of scroll over them, there's like 3 dots that are usually on the whatever the event block is. That's usually the trick to dragging them around as a stack. If you click on that little 3 dots, you should be able to move them around. And if that's not helping, let us know in the chat again, and I can try to figure out what's going on there so that the dragging is a little bit off there.
Okay. All right, guys, I'm going to go back and forth between windows because my other computer is not cooperating with turning the sound off. I don't want any more. We don't want any more incidents with the screeching computer. All right, so then you see, then here's where it would it starts giving you an opportunity to add more actors. So this could be a stopping point where the kids have now learned how to add and resize. And now this is where you can kind of tie in, okay, what other animals live in the ocean? And then you can either provide resources for them to, figure out where they go. This may be something they've already learned, or you can challenge them to write about, or this can be a way to show what they know. So if you've gone to the unit about ocean ecological systems, this would also be a quick way to assess kids and see, how many different fish can they identify and properly put into the system. So I mean, the thing is just the opportunities are endless. Whether you're assessing, whether you're just, looking for something more project-based. But the thing is, the continual theme is that it's a creative way to show it. So I think I would love to have a group of 3rd graders. And actually I just talked myself through an idea of, going into their science, and this be the way that they are assessed on their unit. I think, and again, we're gonna have to start thinking creatively like that, as we're still uncertain about what, fall 2020 is going to look like. And I think engagement is going to be a huge, huge part of this. What area we struggled is that, the lessons had to be, at the very, very least, engaging, because it's too easy for kids to, drift off, even with sitting in front of a laptop. So like I said, Tynker was very, very helpful on that level.
Do you mind if I flip back over and I show a couple different things? Because we talked about differentiation, and I want to touch on that point too.
Oh yeah, because it was one more thing I was going to share with them, David. Outside,
go for it.
And then yes, I will be.
No, go for it.
Okay, can you guys still see my screen? Okay, cool. All right, and then the last thing, actually, and I can probably talk without the slides. I'll share this slide deck with you guys too, and I'll add it. I'll put it into a public. I'll add some more links in there too. Some of the videos that I had that I wanted to share with you guys too. So pretty much one of the things that, like I said, that stands out, just know as we talk about what's to come, is we talk about distance and remote learning tips. This was Tynker really became like my meat and potatoes of my instructional lessons during the remote learning. It definitely ties into the whole screencast for those schools that may encourage teachers to use those video lessons with the Google Meet, because again, the screens and the interface is very user friendly. It was great to use for virtual centers. I used them for my mini lessons that I did with whole classes, and also for centers where students were able to come in and we worked in small groups. David talked about the data, which is awesome. My grades, which were also non-grades during the remote learning. But again, it kind of saved the trouble, because I really wasn't stressing having to go through and grade, because Tynker gave me enough feedback where I could give parents feedback on how their kids were going through. And my favorite thing is it's synced with Google Classroom. We are a Google school. It made my life very, very easy. I was the only electives teacher that was not getting emails about passwords, and my kid can't sign in. And that was really it. And then again, my contact information is here. If you guys have any other questions, feel free to reach out on Twitter, Instagram, email, and I will share this link for the slides in the chat. And I'm done. So I will stop, David, so you can.
Awesome. Let me show a couple of things, and then what we'll do is we'll give you a chance to poke around a little more in there and kind of poke around with content a little bit. So Victor touched on an interesting point. So he touched on differentiation. And so really with differentiation, there's a couple of ways that you can kind of approach assigning things to groups of students or singular lessons to students. Number one is you can have as many classes as you want in Tynker as a whole. And so what I could do is if I had that kid in 5th grade who's like ready for Python, is I could actually just add another class and add that kid to the class. They can stay in the original class, add that kid to the class, and assign them some content there. That's one way. Another way is that, like we said, is that you can create your own projects. And so I can save my own projects. I can create my own projects. And so what's really cool about that is that once I go in and create my own projects, they show up in this My Projects page, and I can assign those to anybody. I can actually assign these to singular students as well. So you could differentiate here where I get this, you see I have this long list of students. You can assign those to singular students from there. And so I can differentiate that a little bit there. Another way.
Is that new this year?
No, it's been there. It's just kind of a hidden feature that a lot of folks don't even realize is there.
I mean, listen, I'm amazing.
And another thing that he touched on too is the remote learning aspect. And so one of the things that, just like any ed tech company, we came into remote learning with a platform that we thought was really good for remote learning, but we learned stuff as this kind of happened. And one of the things that was missing is a way to like chat with students and communicate with students directly in Tynker. I can tell you without a shadow of a doubt, it's in the works. I can't say much more about it. I've played with it, but it's for sure in the works, so you'll see that in the fall. The other thing that you can do, and this is where I'll give you a couple of minutes to kind of play around here, and there is a Tynker Hour of Code page. And so this is free content that you can, and it's separated by grade level. So if I go to like kids K through 2, you have it there. Kids 3 through 5, there's tons of lessons in here, including creating new stuff on your own. One of my favorite pieces in here, though, and this actually works really well for kids at this age, is that there's a UN tab. And the UN tab, if you've ever seen, and I can actually pull these up, the UN has what they call Sustainable Development Goals. And the idea behind these goals is these are goals that the UN has set for the world by 2030. And so they're really good kind of, every time I look at things like creation, I look at it from a standpoint of, can you design scenarios that go around that creation? It adds meaning to it. Mm-hmm. And so one of the ways that you can add meaning is these UN Sustainable Development Goals. Because if you look at these kind of touch every aspect of like core classes. Because when you look at something like decent work and economic growth, the 8th one, that you can do a lot of math stuff around that. There's lots of climate-based ones for science. There's things like quality education and gender equity, which are very social studies based. And so they can become really good avenues into like, can I create in that kind of, and get that great scenario. And what's really cool in the Hour of Code is there's actually lessons here that are based on those. And most of them are science-based lessons, but that you can go and you can create to those UN Sustainable Development Goals. And what's neat is that if you have those kids in 5th grade that are ready for, that you think may be ready for Python, you can actually do Life on Land and Block, and then you can do a version of it in Python. And so it's a great way to kind of progress kids there. You also have NASA lessons here. And so NASA lessons are a great way to kind of have kids go and explore things. And like Lunar Gateway, you can start in Block, and there's a version of it for JavaScript as well. And then there's a couple of text. If you have kids that are really, you're kind of interested if they're really ready for text, this is a great place to start because these are puzzle based and they're very simple text code. Like for instance, it's just like block where you're typing like you're like doing walk blocks, like 1 or 2 walk blocks here, but you're actually writing the Python in Toxic Jungle. And then last but not least, there are a couple of the STEM lessons here where you can go in for free and see those lessons. And Victor actually touched on something that I think a lot of people miss is that when he's sending you the link, you can actually, that's a way that you can share projects. So like, and so if you had, for instance, you can go in and open one of these Hour of Code projects and you can just share the link. You don't even have to have the kids go to the Hour of Code. And so it's a great way to kind of assign and build. And I think the other key piece here with like, especially this grade level is, can you go and have kids create on their own? Can they take the block coding that they're learning in the courses? Because that's really what the courses are for, and build their own stuff. And so if both the kids and you as a teacher, you have this create project button right underneath your avatar. There's tons of templates in here, but you can even start from scratch. So I can go to this blank project template and all it's going to have on it is Cody with a little bit of code. And so it's a great way to start from scratch, to build your own backgrounds, to build your own stuff. And go from there. There's even a point where Tynker's modular and you can even do platformer gaming. So like if I come down here on the left-hand side of the kind of blank project and I come down here to this more button, there's a place over here with game kits where I can build like Super Mario style games in here too. And really the reason I show you this is because the creativity aspect of this is, yes, there's courses, yes, there's curriculum, yes, there's all of that. But the creativity aspect of this is really, really the key. And so really what I want to do is I want to give you about 3 minutes to kind of explore a little bit there. And then what we'll do is we'll come back and we'll kind of wrap up a little bit. I'll talk about like how to join the community, how to get support and more training and that kind of thing. And then of course, if you have questions, we can definitely do the like get on video as well. So I'm going to pause my audio for about 3 minutes and then I'll let you guys come back and we'll do that.
Okay.
one thing that I want to show you before I kind of go into the kind of wrapping up a little bit is really when you go from that creativity standpoint. One of the things that I wanted to do when I first joined Tynker was, can I take a project I used to do in my social studies class and can I convert it to a Tynker project? And this I can do completely for free. This is basically just a blank project that I started. And the idea here is that I used to have kids go in and they would do a commercial for the Industrial Revolution. They would take like the light bulb and they would do a commercial for that project. And what I found, like I said a little bit earlier, is I found kids who I could hand a $100 bill to, and they're not going to go, well, I guess so. If you, she's one of the teaching remotely blogs. I should know that, April. But what I found is that there's kids that I can hand a $100 bill to, and they're not going to put themselves on video. So what I could do is I could say, okay, you can go in and create animations to tell your story and to do your project. And if I can combine it with a future-ready skill like coding and do it for free, that's really, really key. And this project right here is basically Thomas Edison pitching the light bulb, and it's a super simple version of this. All I did was I came into the stage and I got a picture of his lab offline, uploaded it in. I got a picture of Thomas Edison offline, I uploaded it in. You can actually go in the pencil editor and you can see it's not done perfectly, and you can actually erase the backgrounds there with it. I used the draw editor to build my own table, and then I did a costume where I can have the light bulb go and switch back and forth. And really the code here is really easy. It's just speech bubbles with kind of a little bit extra. And you can make this all your own. So like if I press play, remember this is super simple. But the idea is, especially with 3rd through 5th graders, this is like a project that they can get that concept. They'll remember that Thomas Edison created the light bulb, and they can add a lot more to it. And really, that's kind of the key that we want to leave you with, is that this is all about creation. So let me share my other screen one more time. And then we can talk about a little bit of support so you can continue to be creative. And so when you look at kind of the get connected part, I think the key with us is that we want you to get connected on social media, but I'll show you support and training. And really the Twitter stuff, we use the hashtags every student can code and every teacher can code for a reason. Because we believe that coding is something that every kid needs. And I've heard Jamie, and April's already heard me say this, I've heard Jamie Cassup, who's basically the Google educational evangelist that works for Google. He put it out there in a really neat way where he said, there's not everybody's going to need to be a computer programmer. But think about Google as a whole. There are people at Google that sell like YouTube ads. Don't you think that they probably are better off if they understand programming? And so it's really a world where you don't necessarily have to be a programmer, but understanding of it really is going to help you down the line. And then the other part is there's all of the skills and all of the research that comes with coding and computer science. And then I hope you've seen that with Tynker, we try to make it where every teacher can do this and do it well. And so that's really the key piece, is that every teacher can code. There's also the Facebook community where there are lots and lots. We're adding people to that. It's a little bit newer community, but we've added quite a few people to that during the kind of coronation time that we were all on. And then the other key piece here is support. And so we have educator support and technical support. If you need those, definitely email those. I answer most of those on both channels. So if you're looking to connect with me, you can definitely do that. And then the other part of that as well is that you guys that are, especially if you're in the Atlanta area, like when we get out of coronation time and people are actually outside visitors are actually allowed in schools, I'm definitely down to come visit. Linda, not Victor. Victor, we've just met fairly recently, but Linda, who was on a little bit earlier, her school's like 10 minutes from my house, and she always gives me the opportunity to come in and like scratch the teacher itch, which is really nice. And then there's the train.
You're coming. Thank you. Go ahead and Google Map the old 4th Ward.
Oh, I will.
That's all I needed to know.
And then there's the Tynker training page where we're adding a whole bunch of trainings, even to things that aren't Tynker that are going to be more like CS pedagogy. And so that's kind of the key kind of components. Yolanda, if you want to open it up for questions, we can definitely take those. So Taylor, that is actually a really great question. It's something we are definitely very looking at very intently. I think what you're seeing is that some of those courses are a little bit older, especially if you look at like Programming 101. Tynker's been around for a long time. If you look at Programming 101, though, you'll notice that that has changed recently in Programming 101. But it's definitely something we're looking at very intently. I don't disagree with you. I know that as a company, we don't disagree with you either.
So I was going to say, Taylor, one of the things I do, we have a whole, as they mentioned in the interaction where the kids do, we tie a whole lot into like historically Black colleges. The STEP team that I use, actually the kids at camp today created slideshows. And that was actually one of the things that we talked about. So we, again, just kind of where we bring in, you know, and I believe being very honest with my children, having very open discussions. And I think, you know, we all have to do in today's world. And that was how I actually tied it into computer science, is saying, you know, that so that we're not just becoming another way to become a producer of computer science. So that's how I tied in a whole lesson today about uploading images, things that they felt represented, and to you know, kind of take it to the next level. So again, you know, we had it because one of the students actually brought that up. So, you know, Coach Hicks, I can't find, you know, I wanted to add, you know, student or characters into my HBCU presentation, but I didn't find enough. So then we talked about going in and finding things that, so again, another way, that's the thing I love. Tynker leaves it open-ended enough, and it was just a very powerful discussion about representation. So yes, very timely question. But yeah, that was a way that we addressed it in the moment.
Great question. Anybody else?
I think we explained it too well, David. That's
You did such a great job, and the tutorial was easy enough to walk through.
Yep.
We'll definitely be using that. But any more questions before we wrap up? Okay.
Okay, guys. And then also, like I said, I share the thing. Please feel free. I love making new Twitter and social media friends. My goal this year is to have my tech teacher website up, so I'll share that also with you guys. I'm working on it. I'm getting there. I'm like, but
hey, Yolanda, do I need to share the 2 decks with you? I shared the 2 decks that we did with Terry because he did my session Monday, just because I was in one email, but I can share them with you as well. If I need to.
Please do that, and I'll make sure that they get there. But you guys did an awesome job. So with that being said, thank you so much for participating today. We're going to wrap up just a little bit early. We have a 15-minute break, and then panel sessions will be back on the stage.
Awesome. Thanks, guys.
All right, guys. Thanks, everybody.